Helen Thomas and the CDFM study group. We will continue and complete review of CDFM Module 2, Competency 2, Cost and Economic Analysis. Again, this is Helen Thomas and the CDFM study group. We will complete review of CDFM Module 2, Competency 2, Cost and Economic Analysis. If at any time you have questions on anything I'm going over, please feel free to stop me. If you're on the phone line, you can go ahead and ask questions at that time. If you're on the Facebook Live, I've placed the teleconference information there also, so you can call in if you want your responses live, real time. You can do so, or you can leave comments. If you're watching this video later today, you can leave your questions in the comment section, and I promise I will get back in touch with you. If you haven't already subscribed to our YouTube page, please, I need your support. If you can go to our YouTube page and subscribe, leave comments on the videos. If you see something or hear something that's wrong on the video that I may have stated, please send me a note, write it. My feelings won't get hurt. I'll rather present the correct information than be saying something that's incorrect. So your support will be greatly appreciated. Like the videos. If you see something you like, feel free to click that like button so that we can get more publicity on the YouTube platform. All right, so let's go ahead and continue CDFM Module 2.2. So the last week we went through the preliminaries. We went through understanding the acquisition categories, the phases, the milestones. Again, I stopped there because those are extremely important in understanding the remainder portion of this information. At this time, does anyone on the phone line have a question on anything that we discussed last week that you may not have understood, and maybe I need to clarify it for you before we continue? Any questions? All right, no one on the phone line with questions. We'll go ahead and continue. All right, I can only make this information as exciting as your contribution. It is what it is. So it's important for you to review the material before you listen to my videos, before you come on the phone lines, because it'll make it difficult for you to understand what I'm saying if you haven't read the information beforehand. Even if you read it and you don't understand it, I recommend that you still read through it page by page, and then once I go over it, I will try to clarify some things for you. So on the cost and economic analysis, what we're building on is understanding the total cost, the total systems approach from cradle to grave. We want to know how much it's going to cost for us to acquire, develop, research, procure that item, and then once we put it into the field, the existence to fill that capability gap, how do we sustain it? So your operations and support, as we talked about last week, is your most expensive portion of your total systems approach. So I'll say that a couple times to make sure you understand. In the event that you see a question later on and it asks you which particular portion of which phase is the most expensive, I will tell you the sustainment pieces, because the life cycle of an item can take 5, 10, 15, 20 years before that item is no longer good. So let's talk about life cycle on page 2218 of your study guide. Again, I'm just a tutor, a facilitator to help you get through the material. All right, so DoD life cycle. Life cycle cost is the total cost. Again, I say indirect, direct, admin, administrative costs, research and development, anything you can associate it with developing that capability is your life cycle cost, all the way to disposal. So part of breaking down that cost, what it's saying on the bottom of page 18, is they can either do it by the type of appropriation we need, a WBS, which is a work breakdown structure, if you want to break down things so you can see how much portions of the work cost, or life cycle cost composition based on whether it's a research, investment, is it on the operation and support side, is it on the disposal side, what category is that cost. So those are different ways, my nose always itching, in which you can determine cost. On 2219, they introduced the cost analysis requirements description. So check on learning at the DoD level, who's in charge of costs. That's the DCAPE, Director of Cost Assessment and Program Evaluation. No, it's not on the page in front of me, but again, since actually it is. You got to read the paragraph. But since we're talking about cost, we want to know that. So if you look at under the card, it says the foundation of a sound and credible cost estimate is a well-defined program. And the next sentence, the DCAPE requires use of the card and provides guidance on the content. So who do you think developed the cost analysis requirements document? Who creates the acquisition program baseline? Who's responsible for a program? Who's responsible for development of the card? That is your program manager. Anytime your mind goes to acquisition, your program manager should be the top of that list. So the DCAPE is, since he's a top cost guy at DoD, he's responsible for providing guidance in how they develop this card. So a couple of things is listed there. We talked about the acquisition categories last week. Acquisition Category 1 and Acquisition Category 1A are major acquisition programs. So you have your program manager will prepare an authority no lower than the DoD component, your PEO, Program Executive Officer, or office that has several PMs under them will approve the card. So let me say that again. That first bullet on page 2219. For your major programs, major automated information systems, your program manager prepares the card, and your PEO, so let me write that, card is prepared by the PM and your PEO approves the card. So I'm writing on the side of my book. Then it also states in that same paragraph, the DCAPE and the organization preparing the DoD component cost estimate, right? So everybody got to do their cost assessment, must receive the draft. So the DoD must receive the draft 180 days, and then the final one 45 days prior to the overarching integrated product team. So that's a working level group that meets to make sure everything is synchronized. So once they have a date for the OIPT, you backtrack 45 days before that, that final card document must be submitted to OSD and the DoD component preparing the cost estimate. So you have other stuff. All right. Any question on that piece? A lot of information on page 19. The first bullet at the top. On page 20, 2220, you have, now we're going to look at the life cycle cost composition. What specifically makes up that life cycle cost? Couple of things you're going to have to do. You're going to have to calculate. So here we go with formulas. An average procurement unit cost and the program acquisition unit cost. And the best way to look at that is page 2221. Actually, before we do that, Let's go to the diagram at the top of page 20. If you look at the diagram on page 20, it says life cycle cost composition. You see there's squares and rectangles and series inside of each other. So we're going to look at number 1. So the first cost you have is the development cost. Makes sense, right? You're starting off a program, I have development cost. You're going to have to know this without looking at the book. Development costs, you use RDT&E funds, right? You're developing the requirements for that system. Number 2 is called the flyaway cost. You see the little square. Flyaway cost is procurement of the prime equipment, the major end item. So not all the parts that goes to it, not the information systems or that you got to add, not the GPS you got to add to it, just the prime equipment. That's your flyaway cost. So you're going to need to know when they say development cost, okay, that's RDT&E. Flyaway cost, procurement of the prime equipment. What does this mean to you? You're going to see later is if you're giving a list of dollar amounts for RDT&E, procurement, Milcon, O&M, Milpers, and then they're going to ask you, calculate the flyaway cost. Well, if you don't know what flyaway means, you're not going to know that it's only procurement of the prime equipment. So let's continue. Number 3, the term weapon system cost. So when you're looking at those lists and it says weapon system cost, you see that square includes flyaway cost, which is procurement of the major end item, prime equipment, and procurement of the support item. Support and prime together makes your weapon system cost. Number 4 is your procurement cost, which also now you add in procurement of the initial spares for that equipment. So development costs, RDT&E, flyaway costs, procurement of the prime equipment, weapon system cost is your flyaway cost, procurement of the prime equipment, plus procurement of the support item, and then procurement cost is everything that says procurement. So if you're asked to calculate the procurement cost and you get a list of costs and appropriations, then you need to add up everything that says procurement on it. You need to add it up to get the procurement cost. That's number 4. Number 5 includes 1 through 4 program acquisition costs. You add in the military construction of your facilities, Milcon dollars. So when you add development, flyaway, weapon system, procurement, and Milcon program acquisition costs. Number 6 outside is operations and support. What type of funding do we use for operations and support? We use O&M and Milpers to fund that. Disposal is a second set, which is O&M or other as appropriate. So mostly you'll use O&M dollars to dispose of that item. When you put all of those 6 different costs together, that makes up the life cycle cost composition. So I needed to point you to there because when you get to the bottom of 20 with those formulas and they say calculate the average procurement unit cost. Let's couple things. They say average, so I know I'm going to divide something. It says procurement, so I know I'm on procurement costs. So I know everything with procurement. I got to add those up. And when it says unit cost, it's trying to figure out how much for one item. Procurement, program acquisition, unit costs. So remember, program acquisition cost includes RDT&E, procurement, and Milcon. So when you're calculating the program acquisition unit cost, you're going to add up all of those funding And then depending on how many items was already developed, if you divide that, then you're going to find out how much it takes to get a program acquisition cost for development of one of those items. Okay, what is Helen talking about? All right, let's go to page 21 where they have the examples. Any question before we go through the examples? All right, if not, we'll go ahead to the first example. Example of the PAUC cost, program acquisition unit cost. So unit is telling you they're only asking you for one, and I'm emphasizing or re-emphasizing that because if you give the answer for the program acquisition cost, I promise you that answer is going to be on the test. If they ask you for unit cost, that answer will be on the test. Again, as a test writer, that's what we're trained to do. I have no affiliated other than being a CDFM certified individual. I don't see their exams, but I know that's part of writing exams, is whichever direction you can go to come up with an answer, it'll be one of the solutions on the exam. So you got to know what right looks like to know what's incorrect. So we said that program acquisition cost is RDT&E, procurement, and military construction. So for this example, they gave you RDT&E cost for 1 unit, $5,000. Procurement funding for 199 units, $20,000. Milcon cost for $1,000 for your facility, your building, and a total unit 200, total cost $26,000. The PAUC, as they calculate at the bottom here, this first chart, is $26,000 divided by 200. Oh, but let me tell you something. On an exam, you're not just going to get the data you need to calculate that problem. Let me repeat. On an exam, you're not just going to get the number. So they did it real nice for you. They gave you the RDT&E, the procurement, and the Milcon. If I'm writing a test, guess what? I'm going to throw in some O&M, and I'm going to throw in some MilPers and leave it up to you to know you only pull out the 3. RDT&E, anything that says RDT&E on it, procurement, or Milcon, I need to add those up, add the number of units associated with it. The total dollar amount divided by the unit will say how much it costs to develop one of those items. So for this example, the PAUC amount is $130,000. The second example, you will have to also calculate the APUC, which is the average procurement unit cost. The fact that it threw the word procurement in there is your hint to know you're only using your procurement numbers. For the example, they gave you only procurement. Again, in real life, you're not only going to get the data that you need, you're going to get additional, just like in real life. You're going to get additional information. And so you need to know, if I'm trying to get the average procurement cost, I need only to pull out procurement. So for this example, they have 199 units at 20,000. So it's 20,000 divided by the 199 would make my average procurement unit cost 100.5 thousand. So those two formulas you're going to need to know in order to be successful on the exam if you're asked to calculate the PAUC and the APUC. On page 22, they give you again a description of the terms used for the life cycle cost composition. Development costs, RDT&E, procurement or flyaway costs, procurement of the prime equipment, weapon system costs, procurement of the prime equipment and your initial support items. Then you have your procurement costs, which is everything with procurement, program acquisition costs, RDT&E procurement, and Milcon added in. Operations and support, O&M and MILPERS, and disposal is O&M. All right, so that was a mouthful in the last, 10 minutes or so. All right, let's go to page 2223, acquisition program cost estimate. So earlier, I stated that timeline, right, in which that card, which is prepared by the program manager, approved by the PEO, must be submitted. The draft must be submitted 180 days to OSD before that OIPT, overarching integrated product team. And 45 days, the final card must be submitted. So we got to get a cost estimate from the components. So let's look on page 23 under 3 types of cost estimate for ACAD 1 programs. Again, these are your major programs. That initial cost, which is done at the program manager level, which is the card, is the program office estimate. So your program office does, your program manager does the program office estimate, which is basically your card. Then it goes up to the component level. At the component level, that cost estimate is called the component cost estimate. Make it easy. Again, hierarchy. And then when it gets up to the DOD level, who's the cost person at DOD level? The DK. So when it gets to the DOD level, it's called an independent cost estimate. So your 3 estimates: program office estimate, component cost estimate, and independent cost estimate. So 3 types of estimates. That's the various level as that request is being moved up the chain. So they go into work breakdown structure on 24, 25. There's nothing really there for me to point out. I'm going to go to page 26. Cost as an independent variable. I point that out because if you go to the module 4, the acquisition, this particular term is used quite frequently. So you need to know what cost as an independent variable means. So remember when we talked about, let's see, what did we talk about? The risks. There are 3 types of risk in acquisition that they try to mitigate. You have schedule, performance, and cost risk. So if you look at cost as an independent variable, the idea behind it is we want to make sure that we reduce costs earlier on in the process. We don't want to just continue just operate and then we get to the middle or the end of the program and the cost is way out here when we could have cut things, changed things. That's why you have all those decision points. Cost as an independent variable is it's easier to look at numbers, look at dollar amounts, and then compare what we estimated, what we planned versus the actual amount. So the first sentence states, the success of the program is judged by their accomplishments with respect to cost, schedule, performance. Cost, schedule, performance. Am I on point with the cost on what I estimated? If the contractor said they can do the job in 5 months, okay, I'm here, I'm checking. Are we on target to meet that 5 month? Or performance? Is it quality work? Is it to standard? Cost, schedule, performance. Cost as an independent variable. We want to reduce cost. The best time, and actually they have it in the first bullet at the bottom, the best time to reduce cost is early on in the process. And it makes sense, right? You want to save money while you're going through. So 227, we're going to look at various cost estimating methods. So you understand the definition so that when you read a scenario, you're looking for keywords. So when you see it again, it's not going to be, okay, compare one similar system, compare multiple systems, and then you pick analogy or parametric. No, it's going to be a scenario, right? So we're developing this new aircraft, and the only cost we have is a similar system that's in the inventory. And your keyword there is, okay, they have one similar system. So let's look at the various cost estimating method, which on page 2 to 28, we go to the first one. Let's see what it says. Analogy. And anytime you do any cost benefit analysis, cost estimate class, cost analysis class, even on the Defense Acquisition University, DAU, you're going to see these methods again. So analogy says that we have historical information. We're trying to come up with an estimate for development of a product, an equipment. So I need a starting point to come up with a cost as how much is it going to cost to develop. So if you use the analogy approach, you typically have one other similar system in your inventory. So that's your key word, one similar system existing. So it makes it easier, it's quick, inexpensive, easy to navigate that particular approach. Now let's say you don't have that much. So in parametric, the cost is based on physical attribute. So let's say you have a vehicle and it uses GPS and it has other features on it, up armored or different features on it. You may have to take attributes from several, and the cost from several different, like how much it costs to put in the GPS, how much it costs to develop the end item, and several different components. When you put all that cost together, that's your parametric. So parametric is also known on page 29 as statistical method or the top-down. So keyword, they have bolded for you. What this says is I have several similar systems that operate similarly to what I'm trying to do. So how much does it cost to get that one and this one and this portion? So when I put all of those together, statistical, because I'm taking several individual top-down method, is the parametric approach. The third cost estimating approach is the bottoms-up approach, which is the engineering. Couple of things with engineering, and they give you the strengths and weaknesses. So bottom-up is word associated with engineering. Estimating by the engineering method is also known as industrial engineering approach. That's something important. And the third paragraph says the engineering method implies that we have no existing systems to compare. So remember the first one, analogy, we had one similar system already out there. So we have a starting point, a baseline of cost. The parametric statistical one says, okay, I have attributes, things that I want that equipment to do. I don't have an equipment that already does it. So, but I have several systems that have several attributes that I can get the cost of each one, and then I can come up with the top-down approach. Engineering says I have nothing similar to what I'm trying to develop. So no existing systems is your keyword for engineering. What is also important for engineering is the most expensive, right? Time consuming. All of those. So you look at the weaknesses at the bottom of page 30. Very expensive, time consuming, difficult to do, because we don't have anything already out there, right? So you can't do your what if this happened, what happens, and usually performed by contractors. So your engineering approach. And we may already have some equipment already out there. On page 31, you can do the actual cost approach. This approach uses actual costs contracted for or actually incurred on the same system. So it may simply be we needed more of that item developed. So we already have this equipment, we already have this vehicle in our inventory, but we got approval or we need approval for more, so we can use the actual cost to develop that. So those are the various, let me see something here. All right, on page 32, they talk about using expert opinion. So let's say all of that fails. We don't have an existing system. We don't have similar attributes. We don't have engineers who can, we don't have the time for engineers to develop cost benefit analysis. So we use expert opinion. Expert opinion may be in several different experts on their particular field, experts probably being program managers, and then based on the preponderance of the responses, if they have similar responses, you can come up with what's called the Delphi technique. You can use that technique to kind of narrow the information. So if you ask several experts and they pretty much say the same thing, and they all say different things in a certain area, based on their responses, you use what's called the Delphi technique. Is a method that's used to narrow their responses. All right, so those are your cost estimating method: analogy, parametric, engineering, and expert opinion, and what I forget, actual cost. So I forgot actual cost and engineering. And in expert opinion, you use the Delphi technique. All right, any question of anything we've covered thus far? All right, so we're switching gears now. On page 2233 is the learning curve theory. So the idea behind learning curve theory is the longer we do a job, we should be able to produce more, right? We should, actually they say double your workload. So as stated in the slide on top of page 33, as the quantity of a product produced doubles, your manpower should get less. Meaning now I'm becoming that subject matter expert. It should take me less time to produce more items and double my workload. That's what the learning curve theory states. Yes, you're going to have to also do calculations if you're asked questions on the learning curve theory. So we're going to look at that. Let's go to page 34 of your book. About the middle of that, they have some examples of learning curve application. There are two types of calculations that you may be given. Type 1, given the time required to produce a specific product and the learning curve rate, right? It takes 90%, 20%, whatever. You're given the rate, you're given the time, and you must determine the cost, the labor time, or cost to produce double. So think learning curve, think of doubling that production. So the example that is given, they say you have unit number 1, the first unit is going to take you 300 hours at a 90% learning curve. And what do you do with that? Well, if you look at the right there, unit 1, 300 times the 90% learning curve says that it would take 270 hours to produce or double that second unit to that second unit. It's right. So it's going to take you less time, right? 270 hours to produce unit 2, and you take that 270 times your learning curve of 90% is going to take 243 hours to produce that double, which is unit 4. So it depend on what you're given in the problem will determine which approach you take. Type number 2 states that you may be given the production time or the hours, and you may be given the unit, and you have to calculate, or you have to say, what is the learning curve rate? The rate tells you it's a percentage, right? So if nothing else, if you don't remember. So different ways you can do it. All right, I'm going to tell you, actually, let me tell you the hard way first, and then I'll tell you the easier way. All right, so what you would typically have to do is take, for example, bottom of page 34. Let's say your unit 2 is 250 hours. Your unit 4 takes 237.5 hours. You will take 237.5 and divide it by 250. Now that's if you remember how to do your long division without a calculator, just pen and paper. I don't know about you, but sometimes I forget how to do that stuff. So what do I do? Well, if I'm on an exam and the exam gives me several choices. Let's say the exam, always 4 responses in most cases, and they say 80%, 85%, 70%, 85%, 95%. So for instance, I take the answers that's given. And I know that if I multiply the learning curve amount times the hours, I will get the unit. So if you take, let's say, 95% is what I came up with for this particular one. Because I would take 6, so if it's 55, 65, 75, 85, 95, whatever the answers are, option A, B, C, or D on your exam, I take the first one. And if I multiply 250 times, let's say, 65%, am I going to get 237.5? Probably not. If I can take 250 times 75 times 95, or take 250 times that 95%, I promise you the answer will be 237.5. If I take 237.5 times 95%, I'll get 225.6. So if you see what I'm doing here, is in the event that you don't remember how to divide 3 numbers into 237.5 divided by 250, if you can't remember that way, the other roundabout way is to take the responses given in the exam questions and do the same thing you did in type 1 on your scrap paper. And then you'll come up with the learning curve percentage. Any question on that? That's just a tip that I kind of figured out to kind of deal with my weakness. So your learning curve percentage is always the same if you're dealing with like type 2, from unit 2 to unit 4, 4 to 8, 8 to 16. Once you do it for 1, it should be the same for all the other units in that same development. So don't get scared and then try to add different. If you see it's all 95 and then you're like, well, that must be wrong, I need to put 85 or 75, and then you end up getting it wrong. Your learning curve percentage, if you're developing the same item, you're doubling your development, your learning curve percentage in that problem will be the same. All right, what else we got? Contracts on page 35. They go into fixed contract versus cost reimbursable. You can read through those. I'm not going to spend any time on that. I want to go to page 2237, because in the acquisition process, the earned value management is the majority of what you will deal with. What is EVM? Earned value management is a tool that's used to track the performance of cost, schedule, performance of a contract. Cost, schedule, performance is how between the government employee and that contractor is how you guys stay on target to make sure that everything is according to what we requested. So EVM is that tool. You need to know what EVM is. So read through that paragraph. All right, it's about to get, we're about to jump into deeper in with these terms. And so I'm going to go kind of slow just to kind of make sure you understand. In that same paragraph on 37 on the EVM, you see performance measurement baseline. That's that same baseline we talked about when the milestone decision authority approved the baseline. The program manager created the baseline that is used to track your costs throughout the process. All right. So in the middle of that, the third paragraph says EVM is structured. Okay. Each work package consists of a scope. The result is known as the program or performance measurement baseline, which is also called, so you need to know that PMB is equal to budgeted cost of work schedule. Right? Baseline, my starting point, is the same thing as what I budgeted for. So performance measurement baseline is the same thing as budgeted cost of work schedule, BCWS, and it's going to come into play in a little bit. So I'm going to skip most of these. Page 38, you also have some formulas that's listed in bold. Let me look at the top. You have cost variance is the result of comparing actual costs, work performed. I think the best way is for me to go to the diagram on page 39. But just know on page 38, you got the formulas for cost variance, schedule variance, and you need to know those terms. So EVM on the diagram on page 2239. So you kind of have two charts in front of you. Projects, you have project A, B, and C. And what we're doing is we're using the EVM to track their progress. The budgeted cost of work schedule is what we plan for. BCWS is the work, the cost, how much we plan to pay for that amount. So in these examples, for project A, we budgeted for $487. Project B, $250. Project C, $719. And just imagine that the schedule variance is not there. So for now, I'm going to put my finger over the schedule variance amount. The next column over is budgeted cost of work performed. BCWP is the value of the work once it's done. So I'm going to compare the budgeted cost of work schedule, what I plan to pay based on the schedule, and what the budgeted cost of work performed, the value of the work once the job is done. Now you can take your finger off the schedule variance for project A. So project A says, I budgeted based on the schedule, I budgeted for $487. The value of the work once it was done based on the schedule was $487. So I can say that schedule variance was on target. Project B, the planned work, the budgeted cost of work schedule was $250, but once the work was done on that schedule, it was only valued at $217. So you can say that that schedule variance was unfavorable. And option C, or project C, I planned based on the schedule to spend $719, and once the work was done at that schedule, the value of the work was $847. Well, that's favorable, right? Just like when you get an addition to your home, you want the value of your home to go up. You don't want it to be less. You want it to go up. So that's favorable. So again, schedule variance compares budgeted cost of work schedule against budgeted cost of work performed together. That's your schedule variance. So I say this is two charts because if you put your hand over the schedule variance and to the left, Project A has a budgeted cost of work performed. Your value of your work was $487, and then the actual cost that I paid. So now we're talking value of the work versus what I actually had to pay out. So for cost variance, if I'm thinking cost, budgeted cost of work performed, the value of the work is $487. What I actually paid was $487, so I am on target. Project B, the value of the work was $217, but what I paid was $122. So I paid less than what it was valued. Hey, that's favorable, right? Cost variance. Project C, the budgeted cost of work performed. The value of the work was $847, but what I actually paid out was $875. So you will say that cost variance is unfavorable. That is the level you're going to need to articulate the EVM, is if comparing the schedule variance and the cost variance. So any question on schedule variance and cost variance? And so you want your variance, let's see, before I say it, hold on, okay. Provides additional examples. So additional tools for evaluating the contract. Okay, so that's the next page. They're going to give you some charts. I don't want to do that just yet. Let me see. All right, so I think that's it. So EVM is your schedule variance and your cost variance using the same data. So you have two charts in one, is to be able to tell whether you are on target, is it favorable or unfavorable. So how you might see it is not putting not on target, unfavorable, favorable. It might say, okay, your schedule variance is greater than 1 or negative number. So you got to be able to figure out whether it's favorable or unfavorable. So per chart is just different ways, and Gantt chart is different ways in showing the progress of that project. Gantt chart is used for planning and scheduling projects, right? That's why you see you just have the timelines versus the actual how many weeks it takes and so forth, or details in the per chart. So you need to know when you would use a per chart versus a Gantt chart. All right, now we get ready to go into economic analysis. Oh yeah, here we go. All right, any question on anything I've covered thus far on cost analysis, cost and economic analysis? So all of that was primarily the cost analysis side. All right, so economic analysis now is taking the extra step, is reminding us that the value of the dollar today will not be the same at the life cycle of that project. So we have to be able at instances to discount the dollar as we move along in the life cycle to make those calculations. So in the event you have to get to the point where you do an economic analysis, that's what I'm going to show you in this section. So notice different pieces of information that's covered in this section. So economic analysis is that systematic approach that you use to be able to determine the best allocation of your resources. The process is listed on page 44, 45. How to identify your benefits. Your benefits can either be on page 46, quantifiable, where I can put a dollar amount on it. I can say we saved $5 million. We enhanced the operation because we cut back, or we avoided paying for this item and that item, so we cost avoidance. We improved productivity by $2 million. So quantifiable benefits, they're dollar amounts, and they give some examples on page 47 of things you can quantify, put a dollar amount on. However, there are non-quantifiable benefits on page 48. Morale. So depending on what you change in that process, depending on the course of action that you select, it may enhance your morale, security, safety, accountability, adaptability, all of those terms listed on page 49. So understand you have quantifiable and have some examples: cost of savings, cost avoidance, performance enhancement, or non-quantifiable benefits on page 49. All right, so a little bit now of statistics when you talk about economic analysis. And so this section is going to require you to do several calculations: the PAUC, the APUC, the life cycle cost composition. These are all things you're going to have to calculate. So you take it piece at a time, understand it, and then put it together as a whole. So the statistical calculations now begin on page 50 and 51, where we look at the measures of central tendency, the tendency for those values to occur. You're going to need to know how to calculate the mean, median, and the mode, and the so what. Why does it make sense? So you know your mean is your average. That's what that X thing on the top of it means. Your median is your middle value, and your mode is your most repeating value. So it'll tell you how many times that particular value is repeated. So how you will see it again is you might have a list of values 1 through 10, 1 through 5, or 1 through 10, or whatever. And the numbers are going to be all mixed up. The first thing you want to do is put those values in numerical order. So let's say we do numbers 1 through 5, and they have 3, 5, 4, 2, 1. You need to put them 1, 2, 3, 4, 5. Numerical order. That's the first step. Then the second step, you'll be able to calculate your mode. Okay, any of those numbers repeat? So your mode, you don't have any mode because none of them is repeated. Or let's say you have 6 values and you have 5 repeated twice. So your mode in that situation is 5. That's the number that's repeated the most. Your median, if you put all the numbers together, 1, 2, 3, 4, 5, 5. So my middle number is between 3 and 4. So it's 3.5. And then my average is adding all of them up and divided by 6. In my example, 1, 2, 3, 4, 5, 5 is 6 numbers. So I divide all of those, I add them all up. Ooh, and then I divide by 6. Oh, my pen is falling apart. All right, so mean, median, and mode, central tendencies. 2 to 52. Measures of dispersion. So on the graph, on your bell graph, right, up and down, bell graph. So you take all your values, your results of your tests, and then you put them all your values together on this chart. And then you're going to look at the range. Think of taking a test. If you're in a classroom and the teacher gives you a test and you take the exam, and then they take everybody's score on the test. Those are your values. Your range is the larger value minus the smaller value. So whoever scored 100 on the test minus who scored a 60 on the test, right? So that's the range of numbers that you have. And then you have the standard deviation. So on 52, you have 68.27%, 95.45, 99.73, or your 1, 2, and 3 standard deviation is how close are they to the mean. So the mean will be in the middle of that graph, and then all the test scores will be arranged to the left and to the right. So the standard deviation would tell you how tight that data is, 1 standard deviation, 2 standard deviation, or it's a wider range of values. So standard deviation may be used in economic analysis to quantify cost risk, uncertainty, relationship between cost drivers. What's driving the cost? Do they have any relationship to each other, to whatever the values are? So that's your measures of dispersion. So not just knowing how to calculate it, you got to know what's the importance of that value. 2253 goes into the presentation of the data. Frequency distribution. So your frequency distribution can either be through the histogram, or what we call the bar chart or the bar graph, and frequency polygon. So the graphs, the bar graphs versus the dispersion, like your line graph is basically what that is, your frequency polygon, where it just lists the values and you can kind of see, oh, you got a high amount here and then everything drops. You got one value that's real low. So histogram versus frequency polygon. And your data can either be on page 2253, your data is either positively skewed or negatively skewed. So based on the shape of that graph will tell you that whether they have any relationship to each other, or the numbers are skewed, like everybody is getting a 95 and above, might be positive skewed, or everybody is failing that particular question, is it negatively skewed? So the data is telling you something. What can you infer on page 2254? Inferential statistic. Proportion of percentage versus just proportion of your statement. So they give you 2 examples. So you're going to have to calculate the percent change. And let's look at the example. It's easier to understand what you can infer from the data. Example 1 at the bottom, in the middle of page 2254 says, unit supply, you have 100 engine, it's January 1st, you got 100 engines. On February 1st, your engine was down to 75. What percentage, and what's the percent change from January to February? So it's not, remember, I'm asking you for a percentage. I didn't say what was the change, that you just take 100 minus 75 and I'm left with 25 items are sold or gone. No, I'm asking you for the percent change. So you see the formula. The 75 minus 100 divided by 100 times 100, because it's a percentage, and then you have a negative change because it's a negative 25%. The decreased change in inventory, therefore, was a negative change. So I'm asking you if it's a positive or negative change in your inventory. So for this particular example, it's a negative 25. So it's not taking the 100 minus the 75 to get 25. And on a test, you're probably going to see 25, and then you're going to see negative 25%. Read the questions. They're asking you for a percentage. So if you look in the answers and you don't see the percent sign, eliminate that one. And you're probably going to be left with 2 of them that has the percent sign on it. And so for this example, this is a decrease because it went from 100 to 75, and then it caused a negative change. And you could kind of guess that it'll be a negative change because I lost inventory. All right, example 2 says, now we're on March the 1st, and we're back up to our 100 engines. So I dropped down to 75, and that's why I say you don't want to just subtract, because if you do that, in this example, it'll say, okay, I'm back up to 100. By what percentage did the inventory change? They're asking you for a percentage. not 75 minus 100. No, I'm saying 100 engines minus 75, which would be your 25, divided by 75 times 100 will give you, I think it's 33% is what I have. So the increase, because I went from 75 to 100, so I have an increased change in inventory. Therefore, it was a positive change. So if you don't know how to calculate the percentage, know that when your inventory goes out, that's a negative change. And when your inventory comes up, you get more inventory, then that's a negative change, positive change. So the more inventory, that's a positive change. Less inventory, that's a negative change. That's one way to look at it. I'm always looking for shortcuts, right? So in case my brain goes blank and I don't know how to take 100 minus 75, who knows, you might forget. So at least you know that part of the response. So if I know it's a positive change and I see a response and they have a negative number in front of it, I know already I've eliminated the negative numbers because I know the answer has to be a positive. Even if I don't know it's 33 or 25, I know it has to be a positive number. All right. So the next part we're going to look at is correlation. How does data, because again, we deal with a lot of data, and you always ask yourself, so what? You give me this fancy chart, this bar chart, or this per chart, or whatever chart you put in front of me, and I'm going to ask you, so what? Right? Does the higher test scores mean that these individuals perform better in the workplace? I don't know. What's the measure of correlation, the best fit? What you need to know from page 2255, correlation coefficient is a number between -1 and 1, which means the degree to which two variables relate to each other. And let me see if they show it on the other side. So that's what we're going to look at. So I like diagrams on page 56. You're going to have to know positive correlation, negative correlation, or no correlation. So top left diagram is comparing productivity versus examination scores. So the lower, based on this, the lower the test scores, the lower the productivity. And as the people score higher on the exams, their productivity goes up. That's what this is saying. So this is a positive correlation. The second one is a negative correlation. Because this is saying, okay, the high scores cause more errors. And the people with the lowest test scores what? Yeah, so you have to say this is a negative correlation. So positive correlation between training scores and productivity. Therefore, it can be assumed that the higher the training, the higher the productivity. Negative correlation between training and the number of errors. Therefore, it can be assumed, based on this data, that the higher the training score of an individual, the less errors. There you go. I think I was saying that backwards. So the higher they score on the exam, you could say is the less errors they're making. And then no correlation mean if I'm comparing age to examination scores, because the numbers and the points are all over the place, there's not a straight line, it's not coming straight down or going straight up, that it has no relationship between examination scores and age. So what it states in the last paragraph is the strength of the relationship of, so it's either positive, negative, or no correlation. Still continuing with inferential statistics and measures of correlation, they introduced the coefficient of variation. I don't think you're going to have to do any, haven't had anyone that said, hey, I had to calculate the coefficient of variation and all of this stuff. So you can review the formulas there just to be familiar with them. But chances are you won't have to do anything with it. All right, so let's now talk about the fundamentals of cost analysis. Is you're going to have to look at constant dollars. That means when you're trying to come up with a life cycle cost, you're using constant dollars, current dollars. We're going to look at the term sunk costs at the bottom of page 58. So sunk cost is a cost, once you've paid it, you can't recoup it. So sunk cost could be like if you're trying to get a force management contract and you have to do a study contract, so you got to pay money for the study. And let's say you decide, you know what, we're not going to even go forward with it. What you paid for that study contract is considered a sunk cost. All right, time value of money. All right, I got to take a drink for this one from my cup. Because time value of money, and you can see on page 59, present value. The value of the dollar today will not be the same in the future, so I need to discount the dollar to get a good estimate for my total cost of that product. So they give you the formula. I don't think you might have to do it, or they might give you the values, but again, I don't know. Present value, 1 divided by 1 plus whatever that time frame is, the discount rate, and you based on whether it's 1 year, 2 year, 3 years, and so forth. Again, let's put it in action. So on page 60, let's say you have a present value for year 1. I have a product, and the product is a 5-year product. The life cycle of that vehicle is 5 years. So if I'm going to calculate how much those 5 years is going to cost me, I need to discount year 1 at 0.9615. I'm going to multiply that dollar amount times that. Year 2, 0.92, and so forth. What you see there. You can either be given, so at the bottom of page 60, for that example, it assumes a 4% discount rate. This information will be given to you, or it should be given to you. You won't have to calculate. So the 5-year product, you can either read the question that's asked you. Are they asking for calculate the mid-year discounted amount, or the year end? Because most products, we're calculating the year end product. So based on what they ask you, you may have to calculate. So let's go to page 61. And page 61, that diagram, if you can read it, it has analysis of an investment. So we want to make an investment of a product. Based on this, you see the column 1 says the life cycle of that product is 5 years. Year 1, 2, 3, 4, 5. So year 0 is the actual cost that you paid for that first year. Then you have year 1, 2, 3, 4, 5. Item 2 says, I expect to pay every year for this product, expected yearly cost for that first year, I got to pay $10. For the second year, $20, $30, $30, and $10. For a total of $100 expected yearly costs. Expected yearly benefits. That's given. 0, 0. The third year, I expect to make $35, $50, and $75. You would probably be doing number 5 and number 6. So they give you, if you notice, number 4 is the same discount rates. So they use the end of year discount rate for the 4%. 9615, 9246. Okay, that's the year end one. And if you're calculating the present value of cost, that yearly cost, you will take the 0.9615 times the 10, and you will get that yearly cost. If you're going to calculate the present value of your benefit, which is for year 1 is 0, year 2 is 0, that 35 for year 3 times 0.8890, you'll get 31. And then you'll be able to come up with the total present value cost for that, the present value of the benefits, and you'll have a grand total. And then you might be asking on an exam, what is the total present value cost for this investment? What is the total present value benefit for this investment? So that's how you will do that. So that's pretty straightforward. The chart's pretty good for you to review, to understand. If you're given this data, it'll probably be written in a paragraph. It's not going to be a nice little chart like this. So you want to use this as your guide while you're studying, so that you can recreate it on a blank scratch paper when you get in to take the exam. If they ask you, and they'll might say, okay, you're making this investment, it's a 5-year life cycle, it's a 10-year life cycle. It won't be 10 because it's too much. Or 5 years life cycle, then you go 1, 2, 3, 4, 5. And it says the expected yearly cost for year 1 is, expected yearly cost for year 3 is, and then you're recreating this chart for yourself. You will not, probably not see it in a nice structured format on an exam. You will have to recreate it yourself. So that's why I wanted to go over this with you. All right, we're almost there. Don't let me lose you yet. All right, you still with me? Any questions for those on the phone line who can hear me and respond? All right, so let's go to page 2262, break even. So we also want to know at what point, once I invest this money, at what point will I break even so that I can start making a profit, for lack of a better word? Even though the government, we don't make profit, but think of it in that sense. So break even is at what point do I earn my money back? For this example, they have an investment of $1 million, and then you got to calculate the savings. So let's see what it has here. Consider an opportunity for a system that has $1 million investment cost. So initially, I got to pay $1 million, and an annual operating cost of $50,000. So every year, I have to pay $50,000. Then I want to compare it to a new system, a proposed system that has an operating cost of $300,000. Therefore, let me see. The proposed system will replace the current capability that has an annual operating cost of $300,000, therefore saving $250,000 per year in operating costs. How many years will it take to earn my money back? So investment is $1 million, savings is that $300,000 minus $50,000. And then you could see $1 million divided by $250,000. It'll take 4 years for me to break even. Simple as that. All right, so typically I do not go over the examples or the exercises, but for this one, I will, to make sure that you understand what you need to do. On page 2263, for the life cycle cost, so what I was telling you is you will be given the cost data. You'll be given, and you may have more than one RDT&E, more than one procurement, Milcon, O&M Milpers. Just make sure you remember what makes up at the bottom: development costs, flyaway costs, weapon system, procurement costs, program acquisition costs, operations and support, and the life cycle costs. And so based on the development costs, which you know is the RDT&E, for example, is you know that that first one is $400 million. And I'm not going to do all of them, but just make sure you understand. And flyaway cost was procurement of the prime equipment. And so let's see. So prime mission equipment procurement is $600 million. So you use this example to help you be able to pull out the values for the life cycle cost. On page 64, you have to calculate the APUC and the PAUC. So for instance, The problem for the PAUC, after being used for developmental tests and evaluation, proposes 3 units of the weapons system accrued with RDT&E funds. So I'm pulling out the keywords. And then successfully modify and are planned to be deployed to operational command. These 3 items are considered fully operational. That's what we want. Fully operational items, not bits and pieces. I want something fully operated for the acquisition program. There are 297 fully configured items procured with procurement funds. And you remember, program acquisition unit cost is all the costs together, and then you have your average procurement unit cost, just pulling out the procurement piece of it. There are 297 procured with procurement funds, and then they give you the RDT&E with 3 units, and so you gotta be able to pull the data. So that's how you'll see it. It's just a scenario, and you gotta pull out, okay, what do I need to calculate the PAUC? What do I need to calculate the APUC? And then you pull that data out of the response. On page 2265, you have the unit cost in labor hours. So remember, going with your learning curve. So if you read the question, you see they gave you the 90% learning curve. You have unit 1 through 16, and remember, it doubles. So all you're really doing, and you can check yourself, is multiply 90% times 190. You should get 171. 90%, 153 times, 171 times 90%, you should get 153.9. And 153.9 times 90%, you should get unit number 8, and so forth. That's how you do that one. And then page 66 is the opposite way. The learning curve percentage, again, is you got this one. They don't give it to you, but normally what you would do is take that 595 divided by the 700 to get your percentage. Or you could just start with certain numbers, and your learning curve percentage will be the same for units 1 through 16. And finally, on page 2267, your earned value management. That's the tool that's used between the government and your contractors to monitor cost, schedule, performance of a contract, is making sure you know what budgeted cost of work. So learn them in the order. It's easy to remember. Budgeted cost of work schedule. And remember, that was what we planned based on the schedule. Budgeted cost of work performed, that's the value of the work. Get your schedule variance by comparing those two. Your cost variance is you coming up with target on target by looking at budgeted cost of work performed. That's what the value of the work versus what I actually paid, and I compare those two to get my cost variance. So you want to have a favorable, right? A positive cost variance. You want to be on target, or you want to be favorable, but you don't want to be unfavorable. So you got to figure out what that is. So for instance, for what makes an unfavorable schedule variance? Well, if the schedule variance and the performance work is what the value is less, then that's a negative number, right? It's less. So kind of look at those numbers, be able to compare. All right, let's see. So at the bottom, they give you some ways in which to figure out if you forget actual cost of work performed is less than budgeted cost of work performed, the cost variance is favorable. If you remember the definition, I think it'll make it easier for you to know plan versus the value versus actual what I paid. And then that will determine the amounts. Okay, so, and we are right on track for time. So we've just completed CDFM Module 2, Competency 2, Cost and Economic Analysis. Do I have any particular questions on this particular information? Make sure you review the information because it's a lot of it. But once you repetition, and go over it to make sure you understand. Comprehension is what you're seeking in this process, not just memorizing what's on the page, because none of this stuff works independent of the other. All right, if I have no other questions or concern, this concludes our session for today. This is Helen Thomas and the CDFM study group. Next week we will pick up with CDFM. We'll probably go over the fiscal law, I think is what's scheduled for next week. Because again, fiscal law is covered in all three. So I go over the module 3.1 fiscal law portion to add additional fiscal law information to the module 2. I thank you all for stopping by, and I'll see you guys again next time. This is Helen Thomas signing off.